We're now going to look at fine-tuning a flow loop. Initially we're going to operate from a full range of our operating scale, so 20% and through to 80%. We'll let that settle, then look at our trend graph and see what our loop is looking like. The first question is it fast? Yes, it is. We can see that our flow rate is achieving set point very quickly. Is it stable? Well, no. We've got significant overshoot and oscillation. Is it accurate? Well, not terribly accurate. As I say, we've got instability on there. So let's go back and look at fine-tuning. We might start by decreasing our amount of P, because increasing P moves to oscillation, decreasing I moves to oscillation. So let's halve that to 0.5 and oscillate through our 20 to 80% operating range and see what the output is. Once again, letting it settle. Going back to our trend screen, now we're seeing a output quite different. So the questions again, is it fast? Is it accurate? Is it stable? Well, is it fast? No. It is taking about 5 times as long to achieve set point. Is it accurate? It is getting closer. It's still got some level of instability. And is it stable? Well, it's a great improvement. So we can decrease our P further, but we might in fact be better off looking at going back to our I, our integral time. So to decrease that moves us towards instability. Let us try halving. And once again, through our 20 to 80% range. Letting it stabilize. Now we can pause this and just check, see what we're seeing here. So in the first instance we have overshoot on our flow. In our second one we have no overshoot but a very slow response. In our third and most recent one here, we are getting quicker but no overshoot. So returning to real time, let us go and reduce our I further still. Maybe not as big a change this time. Come down to 70. Cycle through our 20 to 80% range. Let it stabilize and look at our trends graph. Now, this last response here, asking the questions, is it fast, is it accurate, and is it stable? We are getting close. We've got something which is achieving a set point in quick time. We have a on set point, so it's accurate, and we have reasonable stability. Now we also look at chasing a slightly underdamped response with overshoot no more than 5%. So just pausing the graph there for a second, turning on our pens, selecting our flow process, we see that our stable flow process is 80%. So coming back to our overshoot, we have overshoot of 3% at 83. So if we were saying that we want a flow response which is slightly underdamped, quarter wave decay, and no more than 5%, we have achieved it with this state of tune. We can achieve it with a variety of other states of tune. 0.5 on your P, 0.7 on your I. It may well be that by reducing our P further and increasing our I, we'll get a similar response. But we will leave it to you now to experiment and find out what is the right for your rig.